Calculate the total work done on the block by the non-conservative forces when the block moved from point A to point B. A diagram displayed on the screen contains all the information provided in the question. The mass of the block is 12 kilograms. Initially, the block is stationary at point A, meaning its speed at this point is 0. It eventually reaches point B with a velocity of 2.25 meters per second. Point B is positioned 4.5 meters above the horizontal. According to the principle of conservation of energy, the work done by non-conservative forces equals the sum of change in kinetic and potential energies. The symbol delta denotes change, representing the final value minus the initial value. Kinetic energy is defined as half of the mass of an object multiplied by the square of its velocity, while potential energy is determined by multiplying the mass of the block by the gravitational acceleration and the height of the object. In our case, the mass of the block is 12 kilograms, and its velocity at point B is 2.25 meters per second. Since the block is at rest at point A, its initial kinetic energy is 0. The gravitational acceleration is 9.8 meters per second square. And at point B, the block is situated 4.5 meters above the horizontal, whereas its height at point A is 0. Consequently, the potential energy at point A is also 0. The change in the kinetic energy amounts to 30.375 joules, and the change in potential energy is calculated as 529.2 joules. When these values are summed together, the total is 559.575 joules. Rounding the answer to two decimal places, the work done by non-conservative forces is equal to 559.58 joules. The mark allocation for this question is as follows: 1 mark for any of the equations on the screen. But it is advisable to always start the solution with the first equation, as there is more possibility of getting the second one wrong. 1 mark has been allocated for correct substitution of the values while calculating the change in the kinetic energy. Another mark has been allocated for substituting the values correctly while calculating the change in the potential energy. And the final mark has been allocated for the correct answer.